Hi scientists, how you going? I'm very good, thanks for asking. Today's video is going to be on acceleration, focusing particularly on gravity, speed over time graphs, and SI units. Let's get straight into it. So guys, acceleration due to gravity. We know that gravity is the force that pulls everything towards Earth. So a falling object will accelerate towards Earth due to that gravitational force. You probably heard the story of Isaac Newton with the apple dropping on his head, and then he came up with the theory of gravitational force. Now what we're looking at here, we've got a skydiver. He looks pretty happy with himself as he's falling down to Earth. Hopefully his parachute's working. When that skydiver is falling, he's going to be speeding up. So that moment that he jumps off of the plane, he's going to be going faster and faster and faster until either he pulls the parachute or he splats onto the floor. Now, there's a value that we can describe for the acceleration due to gravity, and that value is 9.8 meters per second, or 9.8 meters per second squared. So that's the size of gravitational force on Earth, okay? It would be different on other planets. Therefore, the speed of an object increases by approximately 36 kilometers per hour for every second that it falls, okay? Now, on a previous video, we've discussed what this meters per second squared actually means. So the fact that the speed of an object would be increasing by 9.8 meters per second. Now, all I've done is converted that to kilometers per hour by multiplying by 3.6. So that's the conversion to go from meters per second to kilometers per hour. That one's on your formula sheet if you want to check it out. I've done that just because kilometers per hour is a unit of speed that you can probably relate to a bit more because you see it in a car and things like that. So every second, an object will be increasing by that speed. So here we have a picture of a girl. She looks a bit scary, but there she is. And she's dropping a ball off of a cliff, okay? Or it looks like a ball anyway. Now what we've got here is different time intervals, okay? So this is kind of like a motion capture snapshot of what's happening. So at time 0, the ball hasn't been released yet. It's still in her hand. At 1 second, the object would be falling at a certain speed. Can you guess what that speed is? Let's find out. 36 kilometers per hour. Now that's an approximate speed. It might be a little bit less than that. 36 kilometers per hour. How fast would the object be traveling at 2 seconds? 72 kilometers per hour. So the speed is doubling there. What about after 3 seconds? Is it going to be double again? It's actually 108. So hopefully you can see the pattern. Every second it's increasing by 36 kilometers per hour. 144 kilometers per hour at 4 seconds. And then we're starting to get pretty scary at 5 seconds, 180 kilometers per hour. And that would keep increasing. So the longer the object falls, so the higher the distance dropping it, the faster it would go. Now you might ask the question, is there a max to how fast these objects can go? What if I don't know, went up in a plane and dropped something off the edge? Would there be a maximum speed? Glad you asked that question. It's a good one. Objects will not reach enormous speed because of friction with the air. This is called air resistance. My favorite example of air resistance is if you have a pet dog or you see a pet dog and they kind of put their head out the window and the skin just kind of goes back. You can see the effect of air resistance there. Okay, if there was no air, then your face would be completely perfect as opposed to hair going everywhere. Okay, so air resistance actually limits how fast this object can go. I just noticed I stuffed up my hair a bit there. The final velocity of the object is called terminal velocity. So terminal velocity is the maximum speed that an object can take. So it eventually reaches a maximum point. At this point, can I ask you to please pause the video and take down these notes at the bottom. Now, I'm not sure if you've watched the movie Terminal Velocity with Charlie Sheen. He sits down for an hour and just discusses the final points of physics, I believe. I haven't actually seen that one. He looks a bit younger in that movie than he does now. A terminal velociraptor. It doesn't matter what the object is. Eventually, if it falls far enough, it will reach terminal velocity. So my question to you guys, what factors do you think affect the terminal velocity of an object? So what things about the object that's actually falling would affect how fast the maximum speed would be? Because different objects have different values of terminal velocity. In your book, can you please write down as many factors as you can think of? Go for at least 3. If you get more than 5, 6, then you're doing pretty well.